we are heading towards learning about rational exponents. But first, we're going to review over the basic properties for exponents, because the rules for rational exponents are the same as your rules for regular exponents. Okay, so as a quick reminder, we have the product property. So a to the m times a to the n would equal a to the m plus n. So you can see that you are adding exponents. And so as an example 15, x to the 4th times x to the 10th, that would be x to the 4 plus 10 power, or x to the 14th. Another way you can think about this is if you had x to the 4th, so that would be like 4 x's all multiplied times each other, and then you had another 10 x's written out. Then if you count them all up, you'd have 14 x's multiplied together, giving you x to the 14th. So if you kind of can't remember what that rule is, if you write that out, that might be helpful for you. Okay, your next exponent property is power to a power, and that would be something like a to the m to the n power. And you can see here you multiply your exponents. So similarly with number 16, p to the 4th cubed, multiply those exponents, and that becomes p to the 12th. Okay, again, another way you could write that out, when you're looking at this, you have 3 of the p to the 4th powers multiplied together. Okay, so that would be p to the 4th cubed. So you've got that multiplied times itself 3 times. Well, now you've actually turned it into a problem like 15, and you would add those exponents. So 4 plus 4 plus 4 is 12. Okay, so the shortcut is multiply the exponents, p to the 12th. All right, the quotient property. If you are dividing, then you subtract exponents. So it's just the reverse of the product property. Product property, you're multiplying, you add exponents. Quotient property, you're dividing, you subtract exponents. So this would be y to the 5 minus 2 power. So that would be y cubed. Okay, another way you could think of this, if you have y to the 5th in the numerator of your fraction, and then you'd have a y squared in the denominator. Well, if I cross out those y's that I can simplify, then I have y cubed left over. Okay, the zero property, anything to the 0 power is 1. So for example here, 13n, the whole thing to the 0 property, that's just 1. Okay, now that is not the same thing as saying 13 times n to the 0. So if it was written like this and you don't have those parentheses that groups that whole term together, then here the only thing that is being taken to the 0 power is the n. So n to the 0 equals 1, and that would be 13. Okay, so pay attention to where your parentheses are. Okay, negative exponent property. Okay, negative exponents do not mean negative numbers. They mean really little numbers. So if you have a to the negative m power, to rewrite that using a positive exponent, you send that to the denominator, 1 over a to the m. So similarly here, x to the negative 8th power, well, that would be over 1. So do the reciprocal or send it downstairs to the denominator. This would be 1 over x to the 8th. Okay, so now rational exponents. So all of the exponents we've dealt with so far have been integers. Okay, however, you can have a fraction as an exponent, and that's this concept of rational exponents. So here's the rule. There's kind of just 2 things you need to remember. So a to the 1 over n power is the same thing as the nth root of a. Okay, so for example, number 20, x to the 1/3 power. Well, that's the same thing as cube root of x. So those 2 things are equivalent statements. And I guess I didn't give you directions, did I? Okay, so we're going to directions, we're going to rewrite using a radical and simplify. Okay. 21. Okay, well, before we go to 21, go back up here to the second statement. So you have a to the m over n power. So basically, what if that numerator isn't a 1 like it was on the previous one we did? So what happens is that numerator becomes your exponent. Okay, so these two things are the same. Okay, that's the same statement, just written two different ways, but they have the same value. So I'll kind of show you both ways when we get to one that's going to work out for. Okay, so 21. If I rewrite 21 using a radical, so the denominator of your fraction becomes the root, okay, and the numerator of your fraction becomes the exponent. So x to the 2/5 power, okay, so x is under your radical. The root is the denominator, so this would be a 5th root, and then the 2 become your exponent. So the 5th root of x squared. Now, if I wanted to write it this other way, you can, and it would look like the 5th root of x squared. Okay, so these two statements are the same. You can use either one. Does not matter to me, so whatever you prefer. I tend to like the first one. I just like the looks of that first one better myself, but they both mean the same thing. Okay, example 22. So similarly here, the denominator becomes your root. The numerator becomes the exponent. Okay, so when I rewrite this one, the 3 is the root, so that's going to be a cube root of x, and my exponent becomes 10. Okay, so for 22, look at what we have. We have the cube root of x to the 10th. Now, we practiced yesterday with simplifying radicals. So if it's a cube root, I need a group of 3 things to be able to make a group to come out from underneath your radical. So here we have x to the 10. So you've got 10 x's multiplied together. You have plenty of x's to make some groups. You could actually make 3 groups of x's. Okay, that would take up 9 of your x's. You would have 1 more x left over to be the 10th one. And then this is your simplified version. So x cubed times the cube root of x. Okay, 23, the 4th root of 30. So you have the denominator becomes your root, the numerator becomes your exponent. Well, this exponent is just 1, so you don't really have to worry about that. So this could just be rewritten as the 4th root of 30. Okay, now, if I could do a factor tree on 30 and there would be enough to make a group of 4 things that I can take out, I would do that. However, 30, you break that down in a factor tree, you're going to have a 2, a 3, and a 5. So there's certainly not enough there to make a group of something to be able to come out. Okay, 24. So rewrite this one, 8 to the 2/3. So this would be the cube root of 8 squared. Okay, I'm going to show you this one both ways. So cube root of 8 and then squared. Okay, so if we follow order of operations on this first one, well, you would simplify under that radical. So 8 squared is 64. So cube root of 64. If I do a factor tree, take out my groups, this simplifies to 4. Okay, now on the second version, if I do what's inside my parentheses, the cube root of 8 is 2. Okay, so 8 is 2 times 2 times 2. So that's 3 2's. Cube root of 8 is 2. And then after I do that, I would square it. So 2 squared is 4. Okay, so you would get the same answer Again, doesn't matter which way you want to do that. I tend to jump back and forth just depending on what number it is, but either one will work. Okay, 25, 5x to the 3/2 power. Okay, so that 2 is your root. Your 3 is your exponent. Okay, so this would be, because it's a 2, that would be a square root. If you want to write a 2 there, just to remind yourself, that's fine, of 5x cubed. Okay, so I'm going to go ahead and cube my 5x. That's going to be 5 cubed is 125, and then x cubed. Okay, so this is what we have. Well, do you have enough things in here to make pairs that I can pull out pairs? And you do. Okay, 125, well, you just saw it's 5 cubed, so it's going to end up being 5 times 5 times 5. Okay, so you have enough, since it's a square root, I just need a group of 2 things. So I have this pair of 5s that can come out front. And then since I have x cubed, that's 3 x's multiplied together. So I have enough to make a group of x's that will come out. But then there's 1 5 that's left over, and then 1 x that's left over. So there's that version. Okay, we are going to stop there for the moment.